by their global metals and mining coverage team. Just before I get into it, guys, if you want to learn about a sector or industry in a quick way from like really top analysts, go look at equity research reports from leading investment banks. Before you think, yeah, but that's just finance, man. It's not. A lot of the report goes into technology, operations, logistics, so many of the things that make an industry work. It's not just finance, okay? It's not just finance. Finance is just a tool to understand how valuable a particular industry or company is, but you need to understand the inner workings of it before you can get to a valuation. Anyways, so why did I pick lithium extraction, or DLE? Well, lithium is obviously a really important metal, right? It's used to power, the battery that I'm shooting this on, this iPad, and with the electrification of our society, demand for these kind of metals and materials is only increasing. And that has sort of been a tailwind for the industry, as there's efforts now to try and find more efficient, faster, cheaper ways to get lithium out of the ground into batteries, whether that be for EVs or for transportation or energy storage applications or power gen applications, okay? Now, this report here is a really fascinating one because I'll put a link in the comments because it sort of goes over sort of the unit economics of it, the actual technology behind it, and it's sort of which companies or people are in this space that are developing it. So I'm just going to give you guys a brief overview here and a few points from the article that I really like, okay? So the first thing you sort of need to understand is sort of why is DLE even here? Well, you have to take a step back here. What's the conventional way to get something out of the ground? You mine it, right? You go and set up like a massive project, which when I worked in private equity, they did many investments into, or looked at many projects as well in the mining space. And one thing I can tell you actually working on the models is that it's very expensive. CapEx is no joke. And trying to reduce the dollar per ton cost of getting something out the ground is basically the overarching objective here. So given that that is the case, you have high capex, very long production times, we're talking weeks to months here, and low, like average recovery rates of around 60% on average. There's definitely room for improvement. That's with conventional mining of hardcore. The other way you can sort of get it out the ground, apart from just drilling into rock, is extracting it from brine. A brine is just like a solution with ions in it, okay? A simple example would be, I know this is kind of orthogonal, but maybe like tuna in a can of brine. That is an example of brine being very different to lithium. Although there may be mercury in the can, so I guess there's some metal in there as well. So with brine, you sort of have two options. You can evaporate it out. So imagine this was, I know it's a river, lake, but imagine this was a massive pond with brine solution. You basically it will take ages, it says months to years here, to basically get the minerals out of the solution. And then you have to go through a whole process of evaporation, reacting with lithium carbonate to remove impurities, transportation. If you guys, you really have to check this report because it shows here the time span is literally up to 50 days just to get to a final product. Now, in a world where supply chains and markets move on, the drop of a dime, you want to reduce the latency in your supply chain. You want to get stuff quicker. So a method like traditional pond evaporation of lithium out of it it's not the best, is it? And that's where DLE comes in. It basically, number one, the main advantage here is that it reduces the time taken to get the lithium out of the brine. It has a higher recovery rate of up to 90%. Much lower costs, at least on an OPEX basis. However, here it's saying the CapEx is still more or less in the same range. It requires less area, it's not weather dependent, which is a big one actually, because to evaporate something out you need the sun, right? But DLE, you don't even need that. It uses less water, there's no emissions. So it's very clear what the benefits are here, DLE, just both on an operational perspective, it's cheaper, and from an OPEX point, on dollars per ton, it's quicker to get out, it has a higher recovery rate, environmentally friendly and more sustainable. Okay, so then the article goes on to list a variety of lithium projects that are currently operational. The huge markets for this are actually Latin America and all the Americas in general, and there's Argentina and Chile as really big as regions with a lot of lithium reserves. Okay, just as a side point, a really interesting space right now that venture capital funds are investing in is basically any technology to better understand how much reserves are in the ground. Okay, and there's actually quite a few startups that have been like Rio Tinto, which is one of the world's largest mining companies. They do accelerators, and I've seen that they've even invested in companies that are basically developing tools to better estimate reserves in the ground. Why is this a thing? I remember speaking to my old boss once. He worked on maybe billions of dollars of transactions in industrials, and he was telling me basically, before you do a mining project, a lot of the fundraise is basically equity capital to fund drilling. But drilling campaigns aren't always successful. Sometimes they end up being a failure or being very underwhelming. And that's a huge risk for investors. So as a trade, but the way you can sort of circumvent this is now people are using artificial intelligence to basically get a better estimate of reserves in place. When you do like an investment, when you're doing actually technical due diligence on a mining project, I've gone off on a tangent here. Maybe I'll continue this another day because I have to wrap this up. But basically, one of the things you have to do is figure out proven and unproven reserves, and then that is used in something called an evaluation report that is prepared by an external consultant, and that report is used when you go to banks for either debt financing or maybe equity investors to say, hey, don't take our word for it, take this third party who went and did their own estimations and established this. Now obviously if I'm raising capital for a project, my goal is to get as much capital as I can to fund it. I want that report to show that there's as much reserves as possible. So it would behoove me to hire a company who has sort of the best methods or ability to say like, hey, instead of there being like a billion barrels of oil in here, we think there's 2 billion barrels of oil in reserves here. Okay, that's just sort of a side point here. I'm going to do a longer video on this because this article's 30 pages and there's so much data in here, but I guess this is just an intro into it. I personally think this is probably one of the most exciting spaces to be investing in, and by that I mean just like mineral extraction technologies. Just as a side point here, I'll touch on this in the next video, but it's sort of this 3 of the main DLE processes, and this will be super interesting for anyone interested in like chemistry or material science. It's adsorption, ion exchange, and solvent extraction. And I'll try to include the diagrams either in this one or the next one. Regardless, I'll leave a link to the article for you guys to start reading. And yeah, some of these are technologies that are being commercialized for certain applications, but not for lithium extraction. So I guess if you figure it out, you probably can make a lot of money, right? Alright, we'll see you in the next one.